the Arduino screen, and I'm going to kind of step through the code real quick and explain some things that are going on. I've got it pretty well documented here. It's combined sensor inputs and other outputs. Pins 0, 1, and 2 are protected. We use those for the RS485. Pin 13 is the Arduino LED pin, and you should not use it as an input unless you cut the trace on it to eliminate that LED, because the input will not work well. Alright, we set it up to behave like a piece of CMRI headwork called an SUSIC. We will go through that in JMRI. And there's some other notes here. It's we can make it more efficient by not overloading the SUSIC, but we can go through that as we get to it. We'll set card 0 and 1 to be sensor inputs and 2 to 5 to support 128 outputs. Actually, that's not correct. Yes, 0 and 1 are sensor inputs on mine, and I'll show you that too. These are the libraries we should include. Wire.h, and you'll have to download CMRI.h. I will put a link in the show notes to where to download this. The other one is Auto485. This is for the RS485 communications. These are your CMRI settings. We're doing declarations here. So we're defining it as CMRI address 1. That makes it node 1 beginning in JMRI. You'll find that the outputs and inputs start at 1000 as their number. This DE pin 2 is part of the Auto485. Next thing we're doing is we're setting up the Auto485 bus, again, pin 2. Here's where we're going to define the CMRI connection with 64 inputs and 128 outputs. Right here is the inputs, the outputs, and the bus tells it if available to use the 485. Okay, here's the setup. First things we have to do is we have to define whether a pin is an input or an output. And we have a little for loop that says for I equals 3 to less than 20, in other words 3 to 20, increase it, and then set the pin mode to I as input pull-up. For those of you who don't know what input pull-up is, it puts in a resistor so that you do not have to physically put in a 100K resistor to pull the pin up to a high. It's built into the Arduino. It works perfectly. Down here we have 22 to 70. Remember, lesson 21? Okay, I left 21 and 20 open for a reason. They work fine. I left them there should you decide you want to do some I2C work. Those are the pins for it. Pin mode 13 I defined as an output. Alright, the next thing we're going to do is set the serial baud rate. I set this to 19.2, which is the default. Again, you have to make sure this matches in JMRI or it will not begin to communicate. This is critically important. You can bump this, and I tested it. I bumped it up to 28 and it worked fine. So I have not tried any of the higher ones just because of the amount of time it takes to set up the number of sensors to see if it would be valid. This will be nice and safe. Alright, so here's our void loop. Okay? We're going to tell it CMRI process. So it says whatever happens after that we're doing. So here's what we're doing. We're not reading 0, 1, and 2. The first thing we're doing is we're reading digital 3. And if you scroll down, you'll see that we get down to digital 19. And it sets a CMRI bit of 0 through 15. So these are your inputs. And in the notes here, you'll see that the addresses start at 1001 for an input and 1016 for an input. So you have obviously 16 inputs, my apologies. Did you notice we skipped bit 13 skips right here, pin 13 9 goes from 12, and it skips 13 and goes to 14. If you want to increase the number of inputs, let's say you wanted this entire thing to be an input card with 69 inputs, then what you would do is you just create a line for each one of these and digital read that pin. But you have to go back up here and set this eye level to skip 20 and 21, which we did there. So you would just do another pin mode input pull up and make it as high as you want. And obviously you would have to decrease the outputs. It's the same thing. If you only want 5 inputs on it, you can make all the rest of them outputs. It's entirely up to you, but you have to make the changes here, and you have to add the lines here. Guys, I know I could have done a couple of variables and set the variable to make this one work and change this one to increase and then skip from there. I like the individual lines. It keeps my sanity for a quick reference when I go back. So that's the inputs, okay? Next thing we're going to do is we're going to process the outputs. So what we're doing is these are non-servo outputs. They start at bit 100, so it's 1101 in CMRI, okay? So I didn't put the comments in for each individual pin here, and I may do that sometime in the near future in the code. But you can see, you can tell it to digital write pin 22, the bit from CMRI. JMRI tells CMRI to turn an output on or off via 0, 1, 2, all the way on up. You'll see that we ended at 48 here, which is pin 70. Okay? The ending address is 1148. That's a typo there. It should be... No. I'm wrong. It's 1048 and 1001. Okay? That's the entirety of the code. So you can take these pins down, but remember, your bits have to start at 0. So if you decrease the number of outputs, and say you only had 5, then this would be 0, and this one would be 5, and all the rest of those would change, because those bits would be assigned to the inputs, and exactly the opposite.